Hello again. In this video we're going to talk about Huygens' principle. Christian Huygens was a Dutch physicist. He's dead. But he came up with this principle about how light propagates. And what he said was essentially that a light wavefront can be considered essentially a line of individual tiny little sources of light or perhaps sound. So for example, if a wave comes and it hits a particle here, this particle is going to emit its own spherical wave of its own. Okay, so what does that mean? What we're going to see is we're going to animate it in this applet down here. And I think we'll use that to explain some. So here's the applet. And we're going to see a wavefront here coming down and approaching this boundary here, and part of it's going to reflect and part's going to refract. So the angle of incidence here is 45 degrees. First index is 1, which is air. Second is 2. I don't know what that is. Maybe a diamond or something like that. So here's a wavefront. So that's just the first step. The next step we're going to see. So let me pause this a moment. So here on the boundary we have spaced out so we can see it a little bit more easily individual particles, and when the wave strikes them, each one of them is going to emit its own circular or spherical wave. I mean, in this case it has to be circular. We can't represent 3 dimensions on the computer screen, so it will look as 2 dimensions. So here comes our wavefront. You can see when it strikes the particle emits a circular wave. Part of it goes up into medium 1, part of it down into medium 2. Now, medium 2 is a material of higher index, so it travels more slowly here, and it's also at a different angle. Let's go to the next step. So here, and I think in this next step, it's going to connect the wavefronts and show a line. Yeah. So same thing, except now our spherical wavefronts are going to be connected by a line. So you can imagine if you have these particles, if you put another particle in between every one of these, and then another one in between those two, and you have a very dense line of particles, you can see that essentially you're going to get this wavefront that's effectively a line. Let's go to the next step. So here we have just a ray showing the direction of the wavefronts. And this is now beginning to look like some of those standard reflection and refraction applets that we've already seen. So here's the refracted wavefront traveling perpendicular to this ray, and there goes the reflected up there. We'll go to the next step, and this is now going to be a series or traveling wave approaching it, and it's going to look confusing fairly quickly. It's going to look like a big rat's nest, but until that time you can see what's going on. Like right now you can still make sense of it. As you can see, it's starting to look a little confusing there, but you can see you have these multiple wavefronts. The wavelength is shorter than here in medium 1, it's shorter in medium 2. Okay, so there's that. Pause that. You feel free to go look at that one yourself. And that's Huygens' principle. There's more information. You can always, of course, Wikipedia Huygens. Okay, see you next time.